Whether you're making your morning coffee or just using a water purifier at home, you're tapping into this really powerful scientific process, probably without even realizing it. So today, we're going to break down exactly how filtration works. Let's jump right in.
It all kicks off with something super simple, an idea you've probably seen 100 times. You use a sieve, and the sand falls through, but the stones get left behind. Seems pretty obvious, right? But believe it or not, that exact principle is the key to a major technique used in science labs all over the world.
So let's stick with that everyday idea for a minute. We're going to take something you might find in a sandbox and see how it connects directly to some pretty serious science.
The whole secret is incredibly simple. It all comes down to size. The little sand particles are small enough to slip right through the holes in the sieve. But the stones? Nope, they're just way too big. That's really the entire concept. Just hang on to that idea, that size matters, because it's going to explain everything else.
Okay, so if we want to talk about this like scientists, there are a few key terms we need to get down. But don't worry, they're really straightforward, and we'll use some simple examples to make sure they stick.
First up, the main event itself, filtration. That's the official name for this whole process. Now, the most important part of this definition is that word insoluble. So what exactly does that mean?
Well, an insoluble solid is just something that won't dissolve in a liquid. Think about it. If you dump a scoop of sand into a glass of water and stir it all you want, you don't get sandy water, right? You just get wet sand sitting at the bottom. The sand particles stay whole. They are insoluble.
And then you have the complete opposite, a solution. This is what happens when a solid does dissolve, like when you stir salt into water. The salt seems to just vanish. It becomes the solute, spreading out completely inside the solvent, which is the water. Getting this difference is absolutely essential for what's coming next.
All right, enough with the definitions. Let's actually see this thing in action with a classic experiment, separating our old buddy insoluble sand from some water.
The process here is super simple. First, we mix up our sand and water. Then we take a special piece of filter paper, fold it just right, and pop it into a funnel. After that, we just pour our sandy, murky mixture right through it and wait. So, what do you think happens?
Once all the liquid has finally dripped its way through, we're left with two completely separate things. And, this being science, of course we've got specific names for both of them.
And here are our results. The stuff caught in the paper, the sand, that's called the residue. And the clear water that made it all the way through into the container below, that's the filtrate. And just like that, we've separated the mixture. Pretty cool, right?
So, we know what happened, but the much more interesting question is why? What's the big secret behind that little piece of paper? To find that out, we need to zoom in. Way, way in.
So imagine we have this super-powered microscope, and we're looking at the filter paper up close. What would we actually see?
Turns out, filter paper is basically a microscopic sieve. It is packed with thousands and thousands of tiny little holes, or pores, that are completely invisible to us. Now, water molecules are incredibly small, so they can just zip right through those holes, no problem at all. But the grains of sand, they are gigantic in comparison. There's just no way they can fit through. It's the exact same idea as the stones and the sieve, just on a much, much smaller scale.
Okay, time for the ultimate test of our knowledge. We know for a fact that filtration works perfectly on insoluble sand. But what about a solution, something like salt water?
This is a really great question. If it works for sand, why can't we just use this to get all the salt out of the ocean? The answer, the little clue, is hidden in one of those definitions we talked about earlier.
And the answer all comes back to that key difference between an insoluble mixture and a solution. See, sand particles stay big and clunky, but salt dissolves, it breaks down. And here's the real kicker. When that salt dissolves, it breaks apart into particles that are so incredibly tiny, they're practically the same size as the water molecules themselves. So the filter paper can't tell the difference. The little salt particles just cruise right through those pores along with the water. The source material really says it perfectly. The particles of salt in the seawater are small enough to pass through the holes in the filter paper. In the end, it all comes down to particle size. If it's bigger than the pores, it gets trapped. If it's smaller, it passes right on through. That is the fundamental rule of filtration. So, we've totally mastered how to separate an insoluble solid from a liquid. But that just leaves us with a whole new question, doesn't it? What happens if you need to separate two liquids from each other? Filtration isn't going to work there, so what does? Well, that's a puzzle for another explainer.
Thanks for watching.